Let's look at this problem. It's asking how many 4-digit positive integers have 4 different digits. 4 different digits. Okay, where the leading digit is not 0. The integer is a multiple of 5, and the 5 is the largest digit. Good. So this is a typical counting problem. And there are some major characteristics for these integers. So one is it's a 4-digit. And the second one is the digits are different digits. So this one, the leading digit is not 0. So that's kind of straightforward. It's a common requirement. So we will put this aside for the moment. A third major characteristic is all such digits shall be a multiple of 5. And the last one is 5 is the largest digit, so we should not see 6, 7, 8, or 9. Okay, before we handle this problem, I want to mention that when we deal with counting problems, the casework many times is our good friend. So what does it mean? What is casework? A casework is that sometimes by the given characteristics or given conditions, we can subdivide a hard or complicated problem into smaller and easier to handle ones, so that we can downgrade the difficulties or complexities of a problem. So let's take this problem as an example. So what attracts me the most is a multiple of 5. What does that mean? So in order for an integer to be a multiple of 5, its ending digit or the ones digit got to be 5 or 0. So that's a good way that we do casework. So case 1 is we have 4-digit numbers, and we want the last digit to be 5. So case 2, of course, that's the other way. The ending digit is 0. We only have such 2 cases for an integer to be a multiple of 5. There are no other cases. And any integer belongs to case 1 doesn't belong to case 2, and vice versa. If an integer has ending digit or the ones digit 0, of course, it cannot be ending with 5. All right, so the next is what I see is 4 different digits. And also, 5 is the largest. Okay, so we have a 5 now. Let's look at case 1 for the moment. We have a 5 already. So which means that for these digits, the first 3 digits, they can't be 5. So they ought to be 0 or 1 or 2 or 3 or 4. However, the leading digit should not be 0. And that's also a common requirement. Even if it doesn't say so, we should remember that. Then the first digit got to be 1 to 4. It can be any of these 4 numbers. So the first digit can be one of the 4. Okay, then we have 3 left. But remember, we have a 0. The 0 doesn't go to the first digit, but it could be a choice for the second or the third. So we still have 3 plus 1. That's still 4 choices. So we should still choose 2 out of the 4. And then we sort them between the 2 places. One go to the second and the other go to the third, or vice versa. So we have 2 factorial, which is basically 2. All right, so this expression gives the number of digits that satisfies case 1. So we'll leave the computation to the end. So let's look at case 2. Case 2, we have ending 0. Good. Then we don't have to worry about 0. But we still have this. 5 is the largest digit. So we need a 5 in one of these 3 places, right? And we should choose a 5 plus other 2 digits so as to fill in these 3 places. Okay, so how many choices are there? So we should choose from 1 to 4. We should choose 2 from 1 to 4. And then, together with 5, we fill in these 3 places. So 4 choose 2. And then plus 5. We still have 3 numbers to fill in, right? We need to permute them. We need to permute these 3 digits. So that will be 3 factorial. Okay, so now let's compute the expressions. So the first expression for case 1, that equals to 4 times 4 factorial, 2 factorial, 2 factorial times 2 factorial. So we cancel out this, and this is 2, so we cancel with the 4. So that equals to 2 times 2 times 3 times 4, right? This is 4 factorial. So how much is that? So that is 2 times 2, that's 4. 4 times 4, that's 16, times 3, that's 48. All right, let's look at the second expression. So we have 4 choose 2, that will be 4 factorial over 2 factorial times 2 factorial times 3 factorial, right? So that times that gives you 4. And this 4, we cancel with a 4 in this 4 factorial. So basically we have 3 factorial times 3 factorial. So that's 6 times 6, that's 36. So we have 48 integers in case 1 and 36 integers in case 2. So the total number of integers that satisfies all these conditions is 48 plus 36. That is 84. So the answer is D. If you like this video, please subscribe and thumb up. If you have questions, please comment.